What's up, guys? A little lateral area, surface area, volume of pyramids and cones today. It's a simple lesson with some crazy problems. So it's all about just recognizing what shape you got and what formula you need. It says find the lateral area and surface area of the following regular pyramids. So they want the lateral area first. If we check out the old cheat sheet, check out the formula, it's 1/2 times the perimeter of the base times slant height in that scenario. So these are the ingredients we need to be successful. Let's see if we have it. We need the perimeter of the base. Well, being as how this is regular, that would mean that's a square, and it's all 9 yards, so 9 plus 9 plus 9 plus 9, or 9 times 4, which would be 36. And the slant height, dude, we got that also. That's 10 in that scenario. So we can just punch that in, 1/2 times 36 times 10, and get ourselves 180 square yards. So that's a simple one. Then the surface area, we'll start with that formula. If we check him out, this is a pyramid, right? So if we look under that, it's the lateral area plus just one base area this time, because duh, man, pyramids only have one base. We don't need two base areas. So we know the lateral area, it's 180. And then since the shape of the base is a square, I don't need any work shown on squares area or rectangles area or even circles area. So it's 9 squared, which is 81. And then we could punch that in or realize that is 261 square yards. So way too easy on that one. I needed these formulas and these ingredients, and I had everything I needed. Let's see if the rest of them are that easy. So still a pyramid. They want the lateral area and the surface area, so 1/2 perimeter of the base times the slant height. So cool. The base, remember they said they're regular, right? So this base down here, it is kind of hard for people to see that this is the base, it's the triangle. Well, remember it's 777 because it's regular. So cool. So the perimeter of the base, nice, 21. And the slant height, they give me that. This goes from the vertex to the midpoint of a base edge, so that's 12. And we can punch that in. That'd be 1/2 of 12 is 6 times 21. That's a wonderful old 126. So lateral area, 126. No issues there. 126 square meters. Surface area, same old formula. Lateral area plus just one base area, because they only got one base. So surface area is the 126 plus the base area. It's a triangle, so we need to show some work. And we've got two choices. To find the area of the triangle, we've done it two ways. We've done 1/2 base times height, or we've done Hero's formula. And truth is, you can use Hero's formula because you have all three side lengths, because you got to find the perimeter and all that stuff. So you can use Hero's formula. Nothing wrong with it. I want to show you what's up because the homework has got some pretty tough problems on here. Remember, dude, we just spent a whole chapter on 30, 60, 90, 45, 45, 90, SOHCAHTOA type things. So that's going to rear its head. Probably half the homework is about that, so check it out. We really have an equilateral triangle down here. And we spent a long time trying to find the height of that guy. So if I draw this guy in, remember this altitude right here is also the median. So what I'm going to do is I'm going to take this triangle, instead of having it laying flat, I'm going to stand him up to where you're like used to seeing it. So would you be cool with the fact that this is 777 and we just drew in this altitude right here? And since this is isosceles, it's also the median. So that means this is 7/2 or 3.5, but I don't like decimals. But duh, dude, hold your horses. Remember, this is equilateral. We spent a whole chapter realizing, bro, these angles right here are 60 degrees, and that means this dude is 30 degrees. So you get you a 30, 60, 90 right there. And here's the short leg. It's 7/2. So this long leg right here, you just got to take that times radical 3 and get 7 square roots of 3 all over 2. That's how long that guy is. So I'm going to do this. I'm going to find the base area using 1/2 base times height. Remember, we're trying to find the area of this green triangle, or aka this guy. So I know that the base area is going to be 1/2. Remember the base? The whole thing is 7. And the height is 7 square roots of 3 all over 2. Well, what a mess. Holy cow. Well, it's not as hard as you think if you just turn everybody into a fraction. Because, dude, all you got to do is multiply your numerators together. So 1 times 7 times 7, and that radical is just going to come along for the ride. Isn't that totally 49? Radical 3. And then 2 times 1 times 2 in the denominator, that's 4. So boom, there's your base area. 49 square roots of 3 all over 4. And bleh, what a mess. Like I said, you could have done Hero's formula. You would have got something a little different than this because it doesn't simplify the radical. But hey, same thing. But let's compute this. There's no need to go put this in the answer. Like, sure, it is the exact answer, but it's like, this is so messy, we're going to approximate it. So what I do is I'm going to do the 49 square roots of 3 first and hit equals. And then all I got to do is add, divided by 4. Then, right, divide by 4. Now I just add the 126 to it. And that's about 147.2. So about 147.2 square meters. So that one was a lot more challenging than you think just because we needed to find that base area. You could have used Hero's formula, but you're going to have lots of 30, 60, 90, and 45, 45, 90 scenarios on the homework. So I thought I'd refresh your memory. Let's check this guy. Find both the exact and approximate lateral area and surface area of each cone. Sweet. So it's a cone. They want the lateral area. Lateral area. If we check out the formula card, it's kind of weird looking. It's 1/2 times 2 pi r, times 2 pi r, pen freak out, times the slant height. But that's kind of weird, you know, like I personally made that formula just so you'd realize it's half the perimeter of the base times the slant height, because this is the circumference of that circle. But any math textbook's going to totally just call the lateral area pi RL. Well, that's because this 1/2 and the times 2 cancel each other out, and you're left with pi RL. So I'd like it if you wrote this formula down and just crossed out the 2's. And then now let's sub in. Lateral area is going to be pi times the radius, which is 4, times the slant height. No, we don't have it. Well, that's all right. We can go find it. So we have a right triangle in this scenario. So let's go find ourselves the slant height. And it's not going to be 3. You know, our 3, 4, 5, this is the hypotenuse. So we got to do 4 squared plus 5 squared equals L squared. 16 plus 25 equals L squared. And L squared equals 41. So L equals the square root of 41. So we'll put that in our formula. It's just like life. When you're missing something, you got to go find it. Well, they want the exact area. Well, to me, this is unnecessary to put the exact area. We got a combination of radicals and pi's and stuff. It's like, nah, we'll just trump the instructions and go straight to approximate. So I'm going to do 4 pi times the square root of 41. So boom. And that's about 80.5. So about 80.5. And we're in meters, so since this is an area, it's square meters. Surface area, I'm going to write my formula down. It's a lateral area plus 1 base area. And lateral area, I will just write that 4 pi square roots of 41. That's what it really is. Plus 1 base area. Well, since it's a circle, I don't require any words because all you got to do is take the radius and square it. It's pi r squared. So radius squared is 16. Stick a pi with it. And to get the approximate answer, like I said, this is weird to write in there. So we will just take the nasty number, which we still have, and add 16 pi to it. So we kind of overrided the instructions because these exact answers are just way too messy. So about 130.7 units squared for that surface area. Nice. This guy, find the volume of each shape. Kind of bad instructions there. The word both shouldn't be. So find the volume of each shape. This is the pyramid, right? So we'll go find the formula for volume of a pyramid. And that is 1/3 base area times height. Make sure you can find these on your cheat sheet. And let's see if we have all the ingredients. Maybe we got to go find something. Shape of the base, well, we're going to have to assume this is a rectangle, you know. So we'll do length times width, and 12 times 8. Clear. 12 times 8. It's 96. And then the height, we need the height. Dude, that's 10. Nice. So here's the way I like to do it, though. I'm going to save that 1/3 for last. He's kind of weird to deal with, so I'm going to just save that for last, and I'm just going to punch this in. 96 times 10. I really don't even need to punch that in. It's 960. But instead of taking it times 1/3, the same thing is dividing by 3. Like multiplying by 1/3, dividing by 3 is the same thing. So that volume is 320, and since we're a volume, that's cubic feet in that scenario. So feet cubed. So we had all the ingredients we needed there. Sweet. Let's check this guy out. He's still a pyramid. The base, it's kind of hard for some people to see, but it's this guy down here. This is the base. It's a triangle. So volume is going to equal 1/3 base area times height for the volume of a pyramid. And let's see if we got everything we need. I need the base area. It's a triangle. Got to show work on area of a triangle, and we have two formulas, Hero's formula or 1/2 base times height. Well, we can use this one because this isn't just any old triangle, it's a right triangle if you see that box. And I've been asking you to memorize 3 Pythagorean triples, 3, 4, 5, 6, 8, 10, but 10's got to be the hypotenuse, so isn't that guy totally 8 right there? So to substitute in a right triangle, the 2 legs are the base and the height. Like the hypotenuse has nothing to do with it. It's these 2 guys. One of them's the base, and one of them's the height. So 6 and an 8. And then we can multiply that together. That's 3 times 8, which is 24. So that's our base area. Then, putting it back into our volume formula, we still need the height, but be careful, not the height of the triangle like we just used here of 8. We want the height of the pyramid because we're trying to find the volume of the pyramid, so that's going to be a 15. So I'm going to do 24 times 15, boom, and then divide that by 3 to deal with that times 1/3. So that's 120 cubic feet because it was a volume. So volume equals 120. Nice. So now it's time. I turned kids loose in class to try to figure things out. I'm going to have you pause the video and see if you can write the formula and sub in and see why this one is a challenge. This is a good one. Let's see what's tricky about this. So give it a pause and try to find your ingredients. All right, well, they want the volume, so it's 1/3 base area times height. And we start ready to sub things in, and the base area is hard to find because it's this circle right here. So I need the area of the circle. Cool. All I need to find the area of the circle, since circle's area is pi r squared, is the radius. Well, that's this, but we don't have it. So we need to find it. And in class, it took them a minute or two, but most of them realized, oh, can we do SOHCAHTOA? And I said, well, how come you want to do SOHCAHTOA? And they said, well, we have a right triangle, which we do. Don't we have a right triangle right here? And they gave me this angle measure of 52 degrees. So that's cool. We can use SOHCAHTOA when we have a right triangle mixed with some sides and angle measures. So let's figure out which trig function we want. This 12, he's opposite the 52, and r is adjacent to it, so isn't it the tangent? So let's go off to the side and see if we can find that radius. The tangent of 52 should equal opposite over adjacent, 12 over r. And we want to solve for r. And I think you know this is going to come out nasty. Like we've done enough trig to where, yeah, this ain't going to come out very pretty. So last move here is to divide by 52, excuse me, tangent of 52. But there's no need for me to punch that in. I know it's going to be nasty, right? All I cared about is this is the radius. Let's go use this number and put them into our formula. So I got my volume equals 1/3. Remember, the base area is pi r squared. So pi, right there. Then I need the radius. So the radius, we just figured out, is 12 divided by tangent of 52. And then that radius has to get squared. And then times that height, well, it's the height of the cone, which is 12 in that scenario. And this is as exact as we're going to leave it. This is pretty much all we got to do. We have to punch this in our calculator. This is going to be nasty town city. How to punch in? There's lots of ways. Here's the way I like to do it. I like to follow the order operations. Don't we need to do what's in the grouping symbols first? So I'm going to take 12 and divide it by the tangent 52. Hold on, I got to check to see my mode. This is a new calculator. See, I was in radians, so I got to change it to degrees real quick. So, sorry. So 12 divided by the tangent of 52, That's what I'll do. And I'll hit equals, and that's nasty. Let's not round it. Let's keep it exact. And what do I still have to do after that? What's my next move? We'll square that dude. So I'm going to take that guy and just square him. Boom. And then I'm going to save that 1/3 for last, just like we have been doing. So I'm going to take this guy times pi, and then take him times 12. And I got all that stuff in that. Don't wait a second. Sorry. Times 12. Got him. Times 12. Sorry, guys. I took it times 1. So times 12. And then I still have to deal with this 1/3. So instead of multiplying by 1/3, can't we just divide it by 3? So there he is. That is the answer we're looking for. That can be rounded to about 1104 to the nearest 10th, 0.6 millimeters square cubed, because this is a volume. So it's just, that's what the whole lesson's about today. You know what you want the volume. Here's your ingredients. If you're missing somebody, we got to go find it. We got 30, 60, 90s to help us. We got 45, 45, 90s. We got SOHCAHTOA to help us. We got Pythagorean theorem to help us out. So lots of cool stuff. So with that being said, why don't you do this whole number 7. Find the lateral area, the surface area, and the volume. Show all that work. And if you're missing something, just go find it, man. You know, you can do it. So why don't you pause the video and get that guy done. Cool. The hardest part was you needed to find this base edge. So to find the base edge, you got this right triangle here, and it's 3, right? 3, 4, 5. So since this is a square, sorry, I should have told you this is a square. They didn't say that. So this is, the shape of the base is a square. This is a 3. That means this base edge has to be 6. And now that you get the base edge of 6, you could totally find the perimeter of the base, and the whole problem all hinged on that. We needed that base edge. He was the one little missing thing to find. So lateral area was 60 units squared. And then the surface area, you just had to add base area to that, and the shape of the base was square again, so 36. And the volume, 1/3 base area times height, should have got a 48. So it's just about finding the missing ingredients and plugging them in the formula, man. So let's try this one. Let's see what they want us to do. A square pyramid with a base edge 12 centimeters has a lateral area of 192 square centimeters. What's the slant height? A lot of students in class started wanting to draw a picture of this, and there's nothing wrong with drawing a picture, but maybe we don't need this picture. They gave me the lateral area, and sometimes they'll give you a surface area, sometimes they'll give you a volume. If they give you some of these guys that you've got a formula for, let's start with the formula for that shape. This is a pyramid, and see what happens. So lateral area of a pyramid is 1/2 perimeter of the base times the slant height. Always check your formula sheet to make sure you got it right. They want to know what the slant height is, so that's this. Well, we won't know him. Let's see if they give us the other ingredients. So the lateral area, do we know him? Yeah, he's 192. The perimeter of the base, they don't tell it to us. But boy, I bet we could figure it out since it's a square pyramid with a base edge of 12. And we take 12 times 4 and get 48 for the perimeter of the base. And then times the slant height. The next thing I like to do is get rid of the fraction. I want to take everybody times 2. I know it's really not that complicated to take half of 48, but trust me, later when things get more complicated, you'll like to clear the fraction. So I'm going to take 2 times 192, get 384. And then this times 2, and that divided by 2, like end up canceling each other out, so you're left with 48L. And then you can divide by 48 and get L to be, I think it's 8. Let's try 384 divided by 48. Yep, 8 centimeters. Yes, it can be done other ways. You can change that to a 24, but trust me, later we'll have some more complicated formulas, and you'll want to clear the fractions this way. So why don't you try number 9. Write that formula down, sub in, pause that old video, and see if you get it right. They gave you lateral area of a cone, so that's 1/2 times 2 pi r times the slant height, and go ahead and cancel the 1/2 and the 2 right away, and then we'll sub in the lateral area. It ain't 609, it's 609 pi, and then you got a pi times your 21 times your slant height. You got a pi on both sides, and there's only 2 terms, so those are going to cancel each other out in that scenario, and you just divide by 21, so 609 divided by 21 was 29, and then the label was centimeters, so pretty basic. Nice. Couple more, a little story problem. Part of a dish designed for ice cream is shaped like an upside down cone. The base of the cone has a radius of 2 inches, so let's put that in the picture. 2 inches. And it has a height of 1.2 inches. So height, a little perpendicular guy, 1.2 inches. Nice. How many cubic inches of ice cream can it hold? So phase one is to figure out what they want you to find. Do they want you to find the lateral area, surface area, or volume? And since they want to fill this thing up with ice cream, I think we'll find the volume of this cone. 1/3 base area times height. So 1/3 base area, 4 pi, and the height, 1.2. Mixture of decimals and fractions and pies. Let's just punch this guy in and see what we get. I'm going to save the 1/3 for last, so 4 pi times 1.2. And then I'm going to divide it by 3 and get the volume to be about 5.03 cubic inches. Well, since this is a real-life problem, I think we'll just round appropriately, and I think we'll say about 5 cubic inches of ice cream. So, nice. And then the very last one, baby, is this guy, a greenhouse, shape of a square pyramid. The base has sides of 30 yards. The height is 18 yards. How many square feet of glass is needed for the greenhouse? Couple problems. One, we've already indicated they want square feet, and this guy's in yards. But before that, what should we find? Surface area, lateral area, volume, what should we find? So the greenhouse is made out of glass. They're not going to fill the whole thing up, so it's definitely not volume. The question is, should we have lateral area or surface area? Well, the only difference between those is surface area includes the base. So I don't think that if I was building the greenhouse, I don't think that I would make the base out of glass. Don't we just need the lateral area of this guy? So I know I want lateral area. Start with the formula. 1/2 perimeter of the base times the slant height. Now here's the other issue. These dimensions are in yards, and they want the answer in square feet. We got two choices. We could change these guys into feet right now, and then when we find the lateral area, our answer will be in square feet. Or we could leave them yards, find the lateral area, it'll be in square yards, then you have to change square yards into square feet. So I like the first way. I'm going to change the yards into feet. There's 3 feet in a yard. So if I'm going to change this to feet, feet is a smaller unit than yards. That means this number has to get bigger by a factor of 3. So I'm going to multiply by 3, and he's 90 feet. And by the same token, 18 times 3 is 54 feet. So sweet. Let's go to our formula. Lateral area is 1/2. The perimeter of the base is 90 times 4, which is 360, times the slant height. They don't give it to me. We got to go find it. This is the height, not the slant height. So to draw in the slant height, put them in here on the side. And that means we need this right triangle right here. So put a little boxy. This, remember, is 90. So since this is a square, that's got to be half as much of 45. So it's Pythagorean theorem time. Off to the side we go. 45 squared plus 54 squared equals L squared. Remember, we're trying to find the slant height, so we'll use the L. And I'll let you find L for me. 5 plus 2916. Add those up. And I get 4941. Slant height squared. So I'll square root that. I wonder if that's a perfect square. Is the square root of 4941 come out nice? Nope. So we're going to leave him the square root of 4941. So I'm going to go put him in my formula. 4941. And now, what a mess. We'll just punch all this guy in. I got the square root of 4941 punched in already. I'm not going to round him. It's going to take him times 360. Boom. And then I got to deal with the 1/2, so we'll divide him by 2. And that lateral area is about 12,652.6 square feet. So I will say, yeah, that's about 12,653 square feet is what they need. Because it's like, why not round it to the nearest square foot when you're going to get glass for your greenhouse? So pretty simple, yet also kind of complicated. You need 30, 60, 90, 45, 45, 9 SOHCAHTOA Pythagorean theorem to help you find the missing ingredients. Let us know if you have any questions. Have a good one.